Introduction to networking. Why do we need networks? In this lecture, we're going to talk about networks in general. I'll show you what a server is, what a firewall is, routers, switches, a lot of interesting things. Stay with me. It is pretty easy to come up with a definition. Network, it means that you have at least two computer systems that they are connected, they are linked together, they can work together, they can see each other, they can talk to each other. What does it mean? It means that, for instance, if you're at home and you have a router, okay, and they are linked, okay, it means that you have a router and then you have a laptop. What else? You can have another PC, maybe a phone. What else? A printer, a tablet, a modem, a scanner, you know, everything that you can imagine. You know, today you can buy a fridge that is wireless. It means that you can monitor that remotely. It's crazy. And that's what a network is. You have at least two systems that are linked together. They can talk to each other, they can see each other, exchange information. And thanks to that, yes, you can browse the internet, you can go to Facebook, and of course, you can access all local files and documents as well. Here is a nice diagram that I found some time ago. I like to use it because it allows me to help you identify devices and components of a network that we use today. I'm pretty sure you're okay with clients' PCs. That's pretty obvious and we'll not talk about that. Here is something that is more interesting, a server. What is a server? I'm an infrastructure engineer. I use Microsoft, but of course it can be a Linux server. In most companies, that will be a Microsoft server, Windows Server 2008, 2012. In most cases, it will run something that is called Active Directory services. It means that you will have a centralized infrastructure, everything in one place. If you know what I mean, it means files, permissions, printers, policies, everything that you can imagine will be in one place. Of course, you can have more than one server. The idea is the same, that you have a place. For instance, imagine that this PC wants to access a file on that server, and it is my favorite name when I teach. It's Mike and John, so let's use Mike. Mike wants to access a file on a server. You go to the server and say, okay, Mike is allowed to do this or that. I will add him in most cases to a group. It means that Mike became a member of, let's say, HR group 5 minutes ago. It is a good thing because groups are flexible. Why? Maybe next week your manager says, well, Mike, he stopped working at our HR department and he was moved to sales. Make sure Mike is not allowed to access these files anymore. And you don't have to go to 25 places and say, okay, well, what about this file? What about that printer? What about this area? What about that database? You don't have to do that because you have a group. It means that you have to remove Mike from that group and that's it. I want to stop here because we do not have time to talk about servers and Microsoft infrastructure. If you're interested, I think the best place to start is MTA Servers. Okay, it is a really nice certificate from Microsoft that you can get and learn, well, basics, fundamentals of Microsoft servers. Of course, I cannot leave it like that. I have to show you a real server that is Windows Server 2012. Here you can see a nice dashboard, Server Manager. It's new, it's different. If you think about Windows Server 2008 and 2003, it is better. It allows you to identify any issues straight away. Let's try and identify some network devices. Yes, we have a firewall and a router. A firewall is a device that in most cases is responsible for your security and the security of your network. A router in a small office, home office network. In most cases, it is an edge device that is connected to the internet. Yes, thanks to that guy, you can browse the internet, and please note it is a wireless router. And you all go, okay, I don't have any devices like that in my network, and it's still a network. Yes, it is. If you're at home, in 99%, you will have a firewall and a router in one box. It's one device. It's okay. A lot of even companies do that. What about a server? You don't really need a server. Some people go for a NAS server. Okay? A storage server. It means you can have cloud solutions. You can have a service like Dropbox in your own network. You can make backups, manage IP cameras. It is a really powerful device that you can run in your network. That's where I want to stop. In our next lecture, I will show you a firewall, and the router will talk about network devices in our networks. Thank you very much. Introduction to networking. What is a network? Part 2. In this lecture, we're going to talk about firewalls and routers. Just to remind you, here is our simple network diagram, and we are after this guy, this firewall over here. It is designed to make our network secure. I have a Cisco ASA firewall. We'll talk about Cisco devices later on. For now, I just want to connect to that device, Cisco ASA 5505. It is again a small office, home office device. It means it's cheap, easy to manage, not powerful, and good enough if you have 25 users in your network. Let's check it out. Here we go, I am connected. First of all, please note I have my inside and outside interface. And you all go, what does it mean? Inside means that is my inside network, my network. It means that I can expect devices like printers, computers, scanners, phones to be over there. Outside, it is an interface that is connected in most cases to the internet. Okay, yes, thanks to that we can browse the internet, we can go to Facebook and post a message. Oh, I saw a really awesome course delivered by Marius, check it out. Thanks to this outside interface, your device can be connected to the internet. An ASA firewall is a really powerful device that allows you to enable a lot of interesting features. We do not have time, and it's beyond our discussion, to cover things like, okay, how can I enable this or that? I just want to introduce firewalls and show you what's available. First of all, please note there is a section called routing, and you say, okay, what does it mean? It means that this firewall is a router. It means it can route, it can send packets, it can make decisions. Shall I go this way, that way? That's what I said. In a small office, home office network, you can expect to have an all-in-one device. And that's what ASA, that's what Cisco decided to do. They created a device for a small office. Now, please note, of course, there is a firewall. We have VPN, virtual private networks. It means we can work from home in a secure way. The last section is dedicated to device management. It means you can create users and tweak settings that you need. I hope it makes more sense now when you think about a firewall. You can create a lot of interesting policies on a firewall. You can decide Mike is not allowed to browse the internet. This printer should not be available for HR departments and so on. A lot of things that you can enable on a small box like a firewall. That's what I said. A lot of firewalls, to be honest, most firewalls that you can find today, they have a router on board as well. That's why they can be edge devices. They can be connected to the internet directly. Let me say it again. It means that you can combine these two features, make it, create one box here, connected to the internet directly. In our next lecture, we're going to talk a little more about Cisco. I'll show you an ASA 5505, a picture of a firewall like that. We'll talk about Cisco certificates. Stay with me. Thank you very much. Introduction to networking. Network commands that you need. I decided to cover 3 commands: ipconfig, ping, and traceroute. You have to know them. Make sure that you play with these commands. They're available on Windows XP, Windows 7, 8, Windows 7. It doesn't really matter. You will find these commands everywhere. Make sure that you're okay, you know how to use them. To access these commands, we go to Start and we type CMD. Thanks to that, we can access a nice black screen. We can type commands here. I want to keep the commands on the screen as well so you can see them. Let's start with ipconfig. We type ipconfig and press enter. It is enough to produce a really nice output that summarizes TCP/IP settings. It means we can see our IP address, subnet mask, default gateway, and a lot of things that you need to know about your local network. I'm pretty sure you know what an IP address is. It allows you to identify a device. It is like an ID number, okay, or a postcode. It is very specific. It has to be unique in your network. Thanks to that, computers and network devices, they can talk to each other. A subnet mask, I will leave it for now because we have a session dedicated to subnetting. We'll talk about that later on. What is a default gateway? Do you know? In most cases, it is a router, an edge device that allows you to browse the internet. The way it works is, if your PC says, I have no idea how to get to facebook.com, it's not in my network, then if a PC is confused, if it doesn't know, it says, well, I will send it to my default gateway. There is a chance that this guy knows how to get to facebook.com. It's not guaranteed. However, I don't know what to do. I will just go over there. In most cases, it is a router, and a router can help me, can take me to, of course, our favorite website, cisco.com, now facebook.com. You have a lot of switches available for all these commands. What you can do, you can type ipconfig ? You will see all commands all switches that are available for you. I want to show you this one, all. It's really important because you will see more. You will see your DNS, DHCP settings, a lot of important things. What I want to show you is DNS. What is DNS? Domain Name Server. It allows your PC to translate a name into an IP address. It means google.com into an IP address like 5.7.1.7. DHCP is a special server that can give out lease IP addresses. That's where I want to leave because it is beyond our discussion to talk about services like DHCP, DNS. For now, please memorize and understand that DNS allows you to translate a name to IP address. DHCP will give out lease IP addresses. That was ipconfig. Let's check ping. Ping is a very simple command that allows you to check if a host is alive. It means I will ask, mate, are you alive? Can you reply, please? You can ping an IP address or a name. Let's say I want to ping google.co.uk. And google.co.uk says, yes, I am alive, if you're interested. Of course, if you know, you can ping an IP address directly. An example is 8888. You know what that is? The most popular IP address in the world, Google DNS server. If you know, you can ping an IP address directly. Why is it important to know that command? We'll talk about troubleshooting later on. Please note, request timed out. It means that one message was not delivered. Okay, something went wrong. Of course, you can press the up arrow. In most cases, it's a one-time thing, and we're okay with that. It can happen. You can imagine a lot of traffic on, on the internet, and of course, our message is not the only one. That's why it can happen. What you can do with ping, you can keep pinging by using a T switch. Thanks to that, you can leave it even for hours and check if a connection is stable. Traceroute is a command that allows you to see the route taken by a packet. It means you can see all, how we call hops, all routers to the destination. As you can imagine, let's say you go to google.com. Of course, you will go through 20, 25, 37, whatever number of routers, internet service providers. When you use traceroute, it can help you identify an issue. I have CMD open. We type traceroute. In Windows, it's traceRT. And then you specify again an IP address or a host. One switch that you have to use, it is D. If you don't use it, Windows will try and figure out what the name of an IP address is, and it takes forever. That's why you should always follow it and add D. Then let's say I want to go to google.com. Oops, if I spell it. Now it is going to show you all hops, all routers, all internet service providers that are on their way to google.com. Sometimes you will see request timed out. It doesn't mean that there is a problem with that message. Sometimes it means there is a firewall. Firewalls don't like traceroutes, and in many cases they don't report themselves, and that's why you can see requests timed out, even though there is a connection, there is a router, there is a way to get to google.com, you will see requests timed out. I let it finish. Please note trace complete. Our next lecture, Cisco. Thank you very much. Introduction to networking, Cisco. Introduction to the world of Cisco. It's very difficult for me to talk about Cisco in a course like that because it takes years to learn Cisco devices, management, and so on. I will try and give you a very good idea about Cisco certificates, devices, things that you need to know if you want to start your career in IT. Maybe you want to learn a little more about networking. Cisco certificates are really important. If you want to get a job in IT, even if it's a support role, you should get that certificate. CCNA, it's really important to get that, guys. It's really important. A lot of companies, they ask for CCNA. That is something that they require, even if you work with servers, because it proves that you know a lot about networks. It's not only how, Cisco will of course teach you how you can manage a Cisco router, switch. Still, they will show you a lot of concepts and things that you need to understand. Thanks to that, when you get an HP switch, that's absolutely fine to set it up. If you're CCNA certified, it should not be a big problem for you. Then, in a couple of years, if you're good enough, you can go to CCNP, the professional level, and then CCIE, yeah, something that is very difficult to achieve. How can you start? There are 3 points I want to show you. First of all, build your own lab. In my CCNA Real World series, I discussed that in details. It's really important. If you want to work with Cisco, you have to have a lab. You have to have a real network. That's the easiest way to learn. Buy a couple of Cisco devices. It is so cheap to do that on eBay. Play with them. That is point number 2. Break and fix. The easiest way to learn is to break something, then you have to fix it. I have a rack at home, okay? A real rack at home with, 15 different devices. And you can say, well, you are crazy. Yeah, I am. However, it allows me to learn a lot because it's my real network. If something goes wrong, I have to fix it. Want to see my rack? I'll show it to you. Here we go. Cisco switch to HP servers. Then a couple of firewalls, Cisco ASA 5505 and CyberRoam, 2 core switches, 2 HP switches, a backup firewall, and a VMware server. Point number 3, get a job. We have a dedicated lecture to to that point. That's why I'm not going to discuss anything in details. I'm pretty sure you know what I mean. You have to find a job. You cannot lab everything. It's very difficult to simulate all issues, and it's, I can argue it's impossible. That's why experience is so important. We'll talk about that when we get to that section. In our next lecture, we'll talk about Cisco hardware. I'll show you a couple of Cisco devices. Stay with me. Thank you very much. Introduction to Networking, Cisco Part 2. I'll show you a couple of Cisco devices. Here we go, a very popular Cisco router 887VA. Now I showed you an ASA firewall, ASA 5505, that's the box. Over here, it's cute, isn't it? At the back, again, it is a small office, home office device. That's why there is a switch. It means you can connect devices. One thing that I want to mention, it is a PoE device, Power over Ethernet. It means that you can connect, for instance, a voice over IP phone, and you don't need a power cord to it. These two ports can deliver power. Of course, you have to buy a device that is compatible with that standard. Here is a lab that I use to teach Cisco. Please note there is ASA 5505, there is an access point. It's a clip from my CCNA real world labs. Here is an access point from Cisco 1131, a very popular access point. It means you can connect to a device like that using a wireless card. There is a very similar router 881, Cisco ASA 3, 4 switches to be more specific, and a few routers. In this lecture, we talked about Cisco. If you're interested, I encourage you to look at CCNA, CCENT. You will learn a lot about Cisco, how to manage a device like that. If you're interested in security, it is CCNA security. You will learn about firewalls and security protocols. In our next lecture, yes, subnetting. Thank you very much. Introduction to Networking, Subnetting. We are going to talk about IP addresses, subnet masks. I want to make sure that you have a very good idea where to start. We'll have 2 lectures dedicated to that topic. I want to start with IP addresses and subnet masks. Make sure that you understand. I decided to include that in this series, even though it's pretty advanced when you think about that. Subnetting is not difficult. You just need some time to figure it out, to think it through. That's why I like to introduce that straight away, because it gives you more time to understand, to play with it, to watch it again. Later on, it is pretty easy to move to more advanced topics. If I can give you that advice, subnetting is not difficult if you take your time. Make sure that you master all basic examples. You're okay with subnet masks, with private IP addresses, everything that we're going to cover in the next 10 minutes. Make sure that you understand every single word. Later on, it will be, believe me, very easy to move to more advanced topics. Let's get started. Ready? What is a subnet and a subnet mask? You can think of a subnet as a piece of your network. And a subnet mask is something that allows you to answer the following question. Am I on the same network as that printer, as a server, as a router? It is a really important question. Let me give you the following example. There are two PCs, PC1 and PC2. They're connected to a switch. And this switch is connected to a router. That's how we draw a router. Let's say router switch. And of course here, access to the internet. PC1 wants to send a message to PC2. And at the same time, or a second later, PC2 decided to go to Facebook. Yes, let's post some updates. If PC1 and PC2 are on the same subnet, they will talk to each other like that, directly. If PC1, yeah? If PC1 is not on the same subnet as Facebook, and of course Facebook is somewhere else, it is over here somewhere, then PC1 will send it where? To its default gateway. Because PC1 says, well, I have no idea where facebook.com is. It is not in my network. I will send it to my router, because this router should know how to route, how to send that message to facebook.com. It's time to answer the main question. How will that happen? Not sure if you've seen a subnet mask before. Example is 255, 255, 2550. And for now, to keep it simple, please memorize that 255 means match on network and 0 means I do not care. I don't care. Now, two IP addresses. Just, the easiest is the way to understand is to try it out and show an example. 192.168.1.25, an IP address, and 192.168.1.179. Are they on the same subnet? Now, 255 means match. 192.192. Yeah, it's okay. 255. Yeah? The third octet, that's how we call it. 1, yeah, that makes sense. And 0, I don't care. They do not have to match. It means, yes, they are on the same subnet. What if I added 192.168.8.71? Now, we know the first three octets have to match. 192.168, and then it's 8. That's not good, they don't match. This IP address is not on the same subnet as the first two IP addresses. Now let's check the table that I prepared for you over here. We talk about IPv4, because there is IPv6, and in IPv6 the subnet mask is not as important in many cases, but it's beyond our discussion. Our main focus is on something that we use every day, which is IPv4. We have 5 classes of IP addresses. If you decide to go for, let's say, CCNA, MTA in networking, Comptia, whatever, you will have to memorize these ranges, because you can get a question like that on your exam. Please note it's you have to memorize the table. Class A starts with 1 and the last IP address is 126. That's it. There is nothing to understand. You just have to memorize these 5 rows. That's it. One thing I want to mention is that every single group has they have a default subnet mask. And this is something you have to memorize as well. Class A, B, and C over here A, B, and C. Now one more example to make sure you're okay with everything. Let's say I have 10.10.7.25, 10.10.8.129. Can you give me a subnet mask that will make them available on the same subnet? So I want them to be on the same subnet. Can you go for a subnet mask that will make it happen? I hope that you said, well, I can go for class A or class B. Both will work. Class C is not good because the third octet is not the same. It's 7 and 8. That's why it's not good to go for 255, 255, 255. It's okay to go for 255.0.0.0. Even though they match, I said I didn't care. I'm okay. I don't really care. They match, they don't match. I do not care. That's why this subnet mask is okay. And of course, 255, 255.0.0, because the first two octets, they have to match. That's where I want to stop. We'll continue our discussion in the next lecture. Thank you very much. Introduction to Networking, Subnetting Part 2. I will start with one example to make sure that you're okay with subnet masks. If not, please make sure you watch my previous video. 10.10.11.25, 10.10.11.79, subnet mask 255, 255, 2550. Are they on the same subnet? The answer is yes, because the first three octets have to match. That's an octet, right? 255, 255, 2550. I hope it's okay. If not, please make sure you watch my previous video. What is this subnetting all about? You can get a lot of questions. One of them, let me give you an example. 192.168.1.0, and they asked you, can you be so nice and divide that IP address into 5 sub-networks? What does it mean? It means that we do not have enough IP addresses. We do not really need 254 IP addresses, because that's what we have available over here, because with this IP address and the default subnet mask 192.168.1.0, the last IP address is 192.168.1.255. We are not allowed to use the first, we are not allowed to use the last IP addresses. The first IP address is called the network address, and this one is broadcast. Broadcast, it means send everywhere. If I don't know where, I'll send it everywhere. You're not allowed to use 0 to 55. That's why the first IP address is .1 and the last usable is 254. That's why we have 254 IP addresses. What you can get is we don't really need 254 IP addresses. However, we need like 5 subnets and around 25 IP addresses for each subnet. For security reasons, for many other reasons, you will not get 5 ranges. What I mean by that, they could just give you 192.168.1.0, 192.168.2.0, 3, 4, and 5.0. Okay, 5 different ranges. It's, but you just need 25 IP addresses and there are 254. You can say Well, that's a lot, mate. It's not. There are some companies with, thousands of users in one building. It's not enough. And for security reasons, if you want to create a policy, a firewall rule, you don't want to have 500 subnets and networks. You don't want that. That's why a question might be, you need 5 networks. Now, how do you do that? We'll not go through the whole example because that is far beyond our discussion. That is introduction to networking. I want to give you a very good idea where to start. If you're interested, if you go for CCNA or MTA in networking, you will learn everything in details. The idea is that we will play with our subnet mask. Do you remember? 255, 255, 2550. Now, do you remember what I said? The first 3 octets, they have to match. It's for your network. And if they have to match, you're not allowed to touch them. You're not allowed to play with these octets. It means you can do something in the last one. And what you're going to do, you're going to take some bits, because it's in binary, and you will say, well, I will use them for my network. And of course, you will not end up having 254 hosts per network. You will get like, let's say, 16, 32, 64, and so on, because it's again in binary. So you can't be very specific. You can't say, I want to have 25 hosts per network. It's in binary. Of course, there are some other ways you can achieve things like that. Anyway, this is the way it works. You take your original subnet mask and you play with it. You take this octet, because 0, and do you remember 0? I don't care. It's for my hosts. It means I can make that happen. I can take the last octet and divide that into 5, 7, or 500. Or here it's not possible. It would be possible with 00 into sub networks. I hope it makes sense. It's introduction to networking. That's more than enough for now. If you're interested, MTA in networking, you can learn more. Thank you very much. In our next lecture, how to get a job in IT. Introduction to networking. How to get a job in IT. I have 10 minutes to tell you how you can get a job in IT. It is not going to be an easy task. I will try my best, give you some tips and where you can start. Let's start with that table because it is something I like to show to, in a way, encourage people, and it is a good idea to show your salary. It's not bad, isn't it? It all depends where you want to work. Our training is dedicated to networking. That's why we are interested in roles like system engineers, system administrators, maybe software engineer. Project manager should have a very good idea about networking. Database admin, yeah, why not? You know how much you can earn now? How can I achieve that? There are 3 main things that you have to focus on. The most important one is experience. The second one is certificates. Then it is a good idea to have a degree, especially if it's going to be your first job in IT. Experience. It's always tricky because you say, I want to find a job in IT. How can I find a job if I don't have any experience? How can I gain any experience if I can't find a job? we go back to our discussion, make your own lab, create a network at home. That's, I spent like 20 hours recording, I recorded more than 20 hours of videos dedicated to Cisco real world labs, where I, show how you can play with your network, fix, break, see what happens if I press this or that. Of course, it will not replace a real world scenario. It will not. However, in my opinion, it is a very important point. It will allow you to learn a lot. When you get to an IT, to an interview, when they decide to, let's say, send you an email and say, okay, can you pop in and we can have a chat? This is something you can bring up. You can say, yes, I did this or that. Even if you say it was in my lab, in my network. For instance, you can say, well, I have a Cisco ASA as my edge firewall. If I used to be an IT manager, and if I heard anything like that, I would be pretty impressed, because it's not crazy difficult to set it up. However, you have to know what you're doing. It's not, with all due respect, it's not a Linksys router. You have to know something about Cisco if you have an ASA running at home. Of course, there is a chance that you asked a friend. Still, it's pretty easy to figure it out. That's why I do not lie, because I can ask one question and I'll figure it out. Is it a good idea to work in IT? Oh yes, it is. It all depends what you want to do. This training is dedicated to networking. That's why you can work as a network engineer. You can be a project manager. You can be a team leader, an IT manager for a network team. Networking is really important. Even if you're going to be a software engineer, there is a big chance you will have to understand what a subnet mask is, because maybe you're going to design a piece of software that will use some protocols, and then you will have to study even CCNA to code an application that a client asked for. In our next lecture, we'll try and fix a few issues in our network. Thank you very much. How to fix a home network, a small office, home office network. It's not an easy task. However, we have covered a lot of interesting things. I encourage you to watch the second lecture, the second section, network commands that you need, because we will need them. That is, like, you have to know ping, ipconfig. I will add 2 or 3 more commands, and I'll show you how you can fix a network. Every time you start troubleshooting, it is a good idea to follow a method, something that will help you identify an issue and sort it out. You all go, well, but it's like a home network. What do you want? Do you want me to create a plan and implement? And the answer is yes. You don't have to do that on a piece of paper. I want you to think like that. Okay? I want you to think like that. I want to make you aware of things that you can miss if you don't follow a procedure like that. For instance, you receive a phone call from your client or from your friend, and he says, well, my laptop is dead, I don't know, just take it away, I don't really care. You're not going to say, well, let's replace the system board. And just, what? No, what are you going to say? Well, you have to define the problem and get more information. What do you mean it's dead? The screen is dead. If you press the power button, nothing happens. What's wrong with it? It's just, it's not working. That's what, end users say. Or the internet is slow. What does it mean the internet is slow? Want to see an example? Stay with me. Thank you very much. Introduction to networking, how to fix a small office, home office network, part 2. The internet is down, what shall I do? That is our scenario for this lecture. Do you remember? Point number 1, let's define the problem. The internet is down. We need more information. What does it mean the internet is down? You can't go to Facebook, or you try and send an email. What does it mean the internet is down? I can't browse the internet. Maybe it's a local issue, with an issue with a server, with your internet service provider, with a website, with an email server. There are a lot of things that you have to think of, and that's why you need more information. To keep it simple here, we know that the internet is down. We can't browse, we can't print, we can't browse, we can't send any emails. We have tested it on 5 different PCs so far. We know the server is okay. That's it. That's all we know. I want to use the CMD. That's why I want to use that example. What I like to do is, of course, do ipconfig, make sure that I'm on the right subnet. That is my IP address, that is my default gateway. It is a good idea to go one hop at the time. What I mean by that is, you can imagine that you're over here. This is your router that goes to another router, and then you go to facebook.com. This is your router. You paid $25 for it. It's an awesome, cheap router. You're connected to it. Okay, it is a good idea to go one hop at a time. Can I get to that guy? What about this one? What about that one? What if I go down here and instead of Facebook, I will access something else? Okay, we are over here. We're creating a plan. Now, we're going to implement that. Let's give it a go. So we want to go one hop at the time. We'll ping our default gateway, 192.168.1.1. It is a good idea to make sure it is stable. That's why you can use remember? The switches, T, you can keep pinging. Leave it for 1 minute, make sure it's stable. Time is 1 millisecond. That's what you should expect because it's your local network. You don't have to go anywhere. In most cases, you're even directly connected. That's why it should be fast. If you see like 500 milliseconds, that's not good. Please remember, if you use wireless, then it can be much slower. Still, you should not see anything like 300 milliseconds. We're good here. Now, how can I figure out what my next hop IP address is? If you're lucky, you can use traceroute. Do you remember? And let's say google.co.uk. If you're lucky, you will see, here we go. That's the first hop, that's the second hop IP address. That is the default gateway for your router. Your router is going to send that message to another router, and the IP address is over here. You can highlight, right-click, and copy that. Let's ping it. Again, T. Please note, 1 millisecond, stable. Do you understand? Yeah, then it can be more difficult because you can have a firewall and so on, but what have we found so far? That is point number 4. What have we found so far? We know that we can ping our router and we can ping our ISP, Internet Service Provider, because that is our ISP. It means that in most cases, the issue is beyond our ISP. I hope it makes sense. It will help you troubleshoot networks. I want to give you one more example related to wireless, because there are a lot of things that can go wrong, with wireless. We'll talk about that in our next lecture. Wireless troubleshooting. Stay with me. Introduction to networking. Let's troubleshoot some wireless issues. I want to show you one application that you should download straight away and check your wireless networks around you. It's Insider. Just Google it. You will find it without any problems. There is a licensed version. There is a free version. You can see if you need a license for some additional features. Here I want to show you what you can use this application for. The main problem with wireless is it's not reliable, and what you can see is that you can have a lot of wireless networks around you. If they use the same channel, you will have a lot of problems. That's why it makes sense to use an application like that. It will scan your area, okay, around, in this case, a laptop. It will produce a nice graph. Please note, that is my network, MKM, and I can see the channels that are available, that are in use. That is my wireless. You go to wireless and wireless settings. In here, what you can do, you can go for a channel. Auto means I will try and figure out what the best channel is. However, what they don't tell you is that on some access points, well, it's really hard coded. They do not scan the frequency, so I do not trust a setting like that, an option like that on simple routers. It is a good idea to go for channel 1, for instance, in my case. Then you click save. In most cases, it is somewhere under wireless settings, channel, and you can decide what you want to use. It's not easy to troubleshoot wireless. I hope that you will download Insider, play with it. In our next lecture, we're going to talk about your next steps. What can I do next? Thank you very much. Now I have a pretty advanced lecture for you, but do not worry, it's not to show you how to configure a feature that I've got over here. No, it is to encourage you, to show you how amazing it is to go for this career, how cool it is to configure a firewall, a switch, and so on. So here I have a really cool lecture for you. I have an ASA firewall. You've seen this firewall already. And this is a brand new firewall from Cisco 5506. And this firewall has a really unique feature. It has something that is called a firepower service. It means that you can really filter and block whatever you want. It means that you can block, for instance, a website, a service, or even an application. And this is what I want to show you. I have ASA open, and well, we're going to block Firefox. So I have Firefox open. Now let me refresh. I can access the internet, as you can see, and now I will configure my firewall and block Firefox. So over here I have a special rule. Again, it's not really designed, this lecture, to show you how to configure, what is this. No, it's just to give you a very good idea what you can achieve if you decide to go for a more advanced path and certificate. Over here we have applications, and here I just want to show you how amazing it is, how many things you can really block. So please note, I have Firefox on the list, but there are applications that you know very well. Let's say, what can we block? Let's see if there's Outlook. Do you know Outlook? Yeah, from Microsoft. Yeah, so I can block Outlook, an application that allows you to download your emails. Yeah. What else? Of course, Internet Explorer. Just we're talking about applications that can access the internet, and the same applies to URLs. You can be very specific what you want to block, and there are a lot of predefined sections, as you can see. And with just one click, you can say, for instance, okay, search engines. Okay, you're done. Google, Yahoo, and so on. It's really cool. So we have this policy in place. Now we have to apply it because it was disabled. Now we need to apply it and then test it. I will pause the video and come back to you when it's done. I will open Firefox again and we'll test it. Okay, as you can see, policy is up to date on this device. It means that we can open Firefox again and we'll see how it goes. Here we go. As you can see, it's loading. It says waiting for cisco.com. I can't access any websites using Firefox anymore. How cool is that? Just to make sure I can access the internet, the same website using Internet Explorer. As you can see, no problem. Yeah, how cool is that? You don't have to know anything about servers, ports. No, you just say, okay, I want to block Firefox. I don't want my users to access search engines, look for a job, and so on. Again, my goal was not to show you in details how to configure this policy. It was to encourage you to learn more, and I hope that you're going to become a network engineer and come back to me in a couple of years saying, oh, thank you, Marius, it was really cool. Now I can deploy all these things by myself. It's time to say goodbye. Introduction to networking. I always wanted to record something like that, because even if you think about my training general networking, you can say, well, it's the same. It's not, because general networking, we talk about routers, switches, firewalls. I have a lot of labs in it, and it's, you know, it's pretty advanced when you think about some points, and it's like 6 hours of videos. You need time, you have to lab. Here it is like, okay, I have no idea about networking, or I have not touched a router for 5 years. I want to learn something about that in 90 minutes, in 2 hours. That's what I wanted to achieve, and I hope that you enjoyed this series. Thank you very much. Your first challenge, I will ask you to identify a device. You have seen a few network devices already. Now I show you a picture and you have to tell me, or you have to guess what it is. Ready? Here is the first device. What is it? A router, a switch, an access point, a firewall. What is it? Well, this is a small office, home office router that is a switch, an access point, and a firewall in most cases. But if you said, well, it is a router, it is okay, because you can see a WAN port, a wide area port. The gray one, the internet port, allows you to connect this router to the internet. On the other hand, you have a switch, this blue area here with 4 ports. It is a switch. It allows you to connect up to 4 devices, or you can even connect an additional switch and get more ports. What about this one? What is it? What do you think? Well, this is a Cisco 5505 firewall. Again, it is a tricky question because it is a switch as well. Again, it is a small office, home office device. This is why there is a built-in switch as well. What about these devices? What is it? Well, it is a switch. You have a lot of ports that you can use to connect your laptops, printers, computers, and so on. Here you can see some Cisco and HP switches. It is really important for you to identify all these devices, so I hope that you like this challenge. You can always go online, and I recommend doing it. Go online. It can be Amazon, eBay, it does not really matter, and try, just Google around, see what's available. Go to cisco.com and check what they offer. Here we go, I have my cable ready. By the way, it is a really cool cable. Now I take the main unit and turn it on. Here's the remote unit that we're going to use as well. We're ready to connect it all together and we're ready to start. It can take a while, but we should see a wire map on our screen. Please note that we have a 3-meter cable that has been identified as a straight-through cable, and the wire map is okay. We can do the same test without the remote unit. Check it out again, we should see the same wire map without the remote unit. Here we go, we can see all the wires are okay, our wire map is absolutely fine. Now I'll show you how this device identifies a broken cable. We'll see if this device recognizes this issue and tells us where it is. As we expected, we can see the wire map failed. We can see that the white-orange pair is broken. We have seen a few examples already. Now I want to show you a device from Fluke and go through some more advanced labs as well. I take a network cable without a remote unit and we press test. Here we go, the cable is fine, we can see all the wires are okay. Now I want to test a broken cable. I want to check if LinkRunner identifies this issue and tells me where it is. Indeed, we can see that the white-orange pair is broken and has been identified by our cable tester. A really nice device. network security, virtual private networks. In this video we are going to talk about VPNs, virtual private networks in general. We will try and define a VPN, why we should start using a VPN connection, and we'll try and answer a question: is it secure? The first question is, what is a VPN? We can say that a VPN, a virtual private network, is a network technology that allows us to set up a secure connection over a public network. For instance, the internet. That's the easiest definition I can come up with. As you can see on the screen, we have two sites, one in the United States, one in Taiwan. What we want to do, we want to send a message from PC1 to a server that is in the USA. The problem is that this is the internet. We know the internet is not secure. What do we mean by that? Well, we will go through, 50 or 60 ISPs, internet service providers. Anyone can, in theory, look at your message. And that's not what you want. You want to make sure that PC1 can download or send a message, doesn't matter, to or from this server in a secure way. What we mean by that is we want to make sure that nobody can look at our message, or to be more specific, cannot figure out what's inside, because we can't really do that. Just, your ISP, internet service provider, can in theory always look at your messages. The idea is to encrypt your traffic. We are going to talk about it later on. I don't want to get into details at this stage. We'll have a dedicated video or even two to encryption. Again, a virtual private network allows us to create a secure connection over a public network. That's the most common definition you can hear and see. We have two main types of VPNs. You will find that on the internet everywhere. People try and, group VPN connections. There are many different ways of doing that. I want to talk about two main types. It's a site-to-site VPN and a remote VPN connection. The first one is site-to-site VPN. This one, it is over here, and that's what we saw in the previous picture as well. It means we have two sites, two networks, two locations. We want to send a message from this network, from this site, to the other side in a secure way. To make it happen, we need a VPN connection that will be established between these two sites, not between these two PCs, in most cases between these two sites, using a dedicated device. It can be a router, it can be a firewall, it can be a VPN server. In most cases you will have a dedicated device. This PC over here, as far as this PC is concerned, it has no idea it's going through the VPN. Absolutely no idea. It thinks that, well, this PC is somewhere on my network, whatever, I don't really care. I can see I can reach that PC. That is a site-to-site VPN. Sometimes you will hear people call it LAN to LAN, or I think Microsoft like to call it router to router VPN. That is not a very popular term, site-to-site VPN, LAN-to-LAN VPN. What we mean by that, this is LAN, local area network. Let's call it LAN 1. And this is local area network 2. We are going to connect these two sites, again, these two sites. We are going to connect them using VPN, but you are going through the internet. It's not a secure place. We don't trust people on the internet. That's why we need a site-to-site VPN. The second type of VPNs is a remote VPN. It is over here. And in this case, we are at home. What we want to do, we want to connect to a server that is over here. It can be our workplace, or let's say that is our office, whatever, or maybe you're in a hotel and you want to connect to your home network. This is a remote VPN connection. You have a laptop, you have a PC, you have a mobile phone, you want to VPN to this network. That's how we call it, to VPN. We can use that as a verb as well. We can VPN to this network. What it means is we are going to set up a secure connection, but this time between our laptop and our VPN device. Again, it can be a router, it can be a firewall, it can be a dedicated server with a piece of software running on it. It doesn't matter at this stage. The idea is that you are going to set up a tunnel, a VPN tunnel, a secure connection that will allow you to connect to these guys. And the last thing I want to discuss at this stage here with this slide is that when you VPN to this network, you will have this feeling that you are over here. That's the idea of VPNs in most cases. You will feel that you're actually connected to your main network. It feels like you were in the office. That's the idea. Of course, sometimes what you want to do, you want to tell that, well, sorry, if you VPN, you will not be allowed to access this server. I don't know, for some security reasons. I don't know. It can happen. It's not a very common solution, because if you can VPN, then you should get access to things that you use every day. Still, it can be achieved using, for instance, access list policies and so on. Again, site-to-site VPN and remote VPNs. We have a lot of VPN protocols, and we are going to discuss them later on. Now I want to mention that there are protocols that were designed to make VPN work. Yeah, we need something that will allow us to create this site-to-site VPN or a remote VPN tunnel, and we use dedicated protocols to make it work. As you can see on the screen, I listed 4, in my opinion, the most popular protocols. There are some other protocols, or you can group them again in many different ways. PPTP, L2TP, IPsec, and SSL. The first two, again, I will not get into details because we'll cover that later on. PPTP and L2TP, they are really popular because there is a client built into Windows. You don't need to download anything. That's easy. PPTP is not secure anymore. We should avoid using it. IPsec is really a standard for VPNs today. If possible, we should use IPsec and avoid using especially PPTP. L2TP can be combined with IPsec. SSL is a new flavor of VPN, if you wish, and I noticed that people have deployed a lot of SSL VPNs in the last couple of years. It has become really popular. I'm pretty sure you all go, okay, what is SSL VPN? It's like, just, what's that? Again, we'll have a dedicated video to SSL VPNs. The idea for an SSL VPN is to make your life easier and allow your users to connect to your network using a web browser. It means that they will open Firefox, Chrome, Internet Explorer, whatever browser they want. They will type an IP address or a name, let's say company.com/SSL, whatever name you dedicated to that service, and they can connect to the network. Awesome. You don't need a client, you don't have to set up anything. No, in a way, you browse the internet. And that's what your users love, because it is simple. As you probably know, all users know how to browse the internet, right? That's what they do. They go to Facebook, YouTube, whatever, Twitter. When you try and teach them how to use PPTP or, let's say, Cisco IPsec client, they say, that's really complicated, mate. When every time I show someone an SSL VPN option, they go, wow, that's it? Really? I just put my username and password. It's like going to Facebook, mate. Yes, it is very easy. You open a web browser, you can access your corporate network. Again, there will be a dedicated video to SSL, and we will discuss that in details, and I am going to show you an SSL VPN, probably on an ASA Cisco firewall. Is it secure? Well, it all depends if you have set it up in the right way so far, and make sure that you go for the best protocol possible with the best options possible. We'll talk about encryption, authentication, options available for your VPNs, and what is the best available. However, sometimes it is not that easy. There is a chance that your device will not support IPsec VPNs, something that you should use. For instance, if you want to set up, let's say you have a home network, yeah? You are a home user. Let me just show you that, what I mean. Let's say you are over here. That's the internet. That is your home router. Let's say, I don't know, Linksys. And this is your network. Let's say you have a server here, a NAS server, a very popular device that you want to access. Of course, there are many other ways available for you to access it. I will focus on VPN here. You want to VPN to your network, right? What's the problem? Well, the problem is that you will have to check if your device supports VPNs at all. There is a big chance it's not an option. If you bought a router for, I don't know, £40, do not expect any VPN options on it. At all. Do not expect that. You have to pay much more to have PPTP. That's the basic VPN. Not sure if you remember, we discussed that a few minutes ago. If you want to have something better like SSL, do you remember, the web browser-based VPN, or IPsec, well, that is £100. Of course, there is a way around. We can use OpenVPN, we can use, for instance, for Linksys routers, we can use an alternative firmware image. Still, if you want to go for VPNs, you will have to invest some money. That's the only way to make it happen. Of course, there are options that I prepared a lab for you, TeamViewer. There are some free options available for you, but believe me, if you want to use that every day and it is a serious project and you want to have a reliable connection, you will go for a piece of hardware. You will have a dedicated router, a dedicated firewall, or a dedicated server, a Microsoft server, a Linux server, if you know how to use it. You will have a dedicated device that will be responsible for connecting for your VPNs. In this video, we talked about virtual private networks in general. We discussed VPNs. I answered the question, why should I start using a VPN? And we mentioned a few things about the security aspects of VPNs. Thank you very much. How to map a network drive in Windows 10. If you go to File Explorer, there is a wizard that allows you to do it. You can map a network drive or add a network location. Let's go for this option. Next. Again, you will have to wait for Windows 10 to discover all devices. Let's go for yoga. It should ask me for a username and password. Here we go. I will put it. Here we go. And then you go for a folder that you want. Let's say I want to go for users. It does not really matter. Then you go for next. You name it. Test folder, next, and then you can open it straight away. Here we go. And now when you go to this PC, you have it under your network locations. When you go for this option, you can map a drive and have a drive, a letter that you want. Not a shortcut, but a drive. It's the same screen. Here we go. Now when you go to this PC, you have an O drive. You have a drive, not a file folder. You have a network drive. It means that when you go to run, you can literally type O and it will take you to your network location. It's up to you. Both solutions are okay. Most network and system guys use this second solution. You know how to map a network drive. Again, if you're interested, please join any course dedicated to networking if you want to learn a little more about all these options. Hi guys, we'll try and take a look at our rack, see what's inside, what we want to do, where we want to put our devices. Okay, so here is my rack. Let's take a look. First of all, you can see two fans. They are USB fans, my IP phone, a voice router that we don't need. We have to remove it because I have a new router over here. We'll see. I think I will use the first 4 or 5 years to mount all devices, including core switches. Then 2 servers that will stay in here, firewalls, that's fine, and here you can see 2 core switches, 3550s, that we are going to remove. What I like to do, especially in a project like that, it makes sense, if possible, to leave routers in the rack, just in case. It's very easy to roll everything back. Let's say in 2 or 3 hours you realize, oh, I can't connect to my server, I can't VPN, whatever. It takes like 3 minutes to reconnect all cables and you can roll it back. I think that's what I am going to do, just in case I will leave core switches in place. Of course, you can unplug the power, that's fine. Cable management that we have to sort out. Here 2 access switches that will be left as well. However, as you know, we are going to add a gigabit switch because I need more gigabit ports. Yeah, you can see these switches, they have 2 gigabit ports only and all are in use. I need more than that. I have a big server here that runs VMware. I have 2 servers here with gigabit ports. I have a PC with a gigabit port, access point. I need at least 6 gigabit ports. That's why I decided to go for a gigabit switch. Here you can see a really nice fan, and it is quiet because it is a USB fan. I know it will not produce as good flow as, you know, a rack mounted fan trays, things like that, but it is quiet and it's more than enough to keep these devices in a good shape. Okay, it's not bad. As you can see, a LED. I love things like that. These fans are have LED lights as well. I know, it's just me. I like to play with things like that. I think we are going to remove this old voice router, and we have 1, 2, 3, 4, 5 use, more than enough. We need 3. We have 2 core switches and 1 access switch. I should be okay with cables because they're pretty long. As you can see, I route cables on the left and right hand side with some cable ties. That should be okay. Here at the bottom, not sure if you can see that. Okay, hope I can see it now. There is an old APC UPS that I am not really happy with because the power went down a few weeks ago and it died, even though there are just 2 HP servers connected to it. I don't know why. It's just it didn't work. That's why, again, as you know, we're going to add a proper UPS, connect a few devices, make sure it is stable.
How to create and understand a network diagram. Network diagrams are really important if you want to start troubleshooting an issue. And please make sure that you create a network diagram for even your home network. Put a router, a PC, a server, laptop, whatever. I'm going to show you how you can create a network diagram in Microsoft Visio. Of course, there are a lot of applications that you can go for. However, in the real world, I think Microsoft Visio is the most popular one. We go for File, New, and in here you will have some predefined templates. You have a basic network diagram or diagram, and of course we want to go for detailed network diagram. Let's create. Here you will see a list of devices and objects that you can go for. You have routers, servers, and you can download lots of additional objects from the internet. You have, for instance, Cisco prepared an object for, I think, every possible router, switch, and access point. So here, when you just search for Cisco, you will not find anything. However, you can download that from the internet. I'll show you that. Here we go. I just googled Cisco Microsoft Visio, and here is a list of zip files that you can download. Of course, it's for Cisco, and I'm pretty sure HP and all other companies, they prepared similar files. What do we want? Let's say we want 2900 routers. I just want to show you how it works and what you can expect. Okay. Here we go. And that's what we've got. Let me just copy that guy and paste it to our projects. Here we go. I will zoom it in for you, and we have a Cisco router. Okay, of course you can resize and you can see that in details. Okay, let's check some more. Here you have front, rear, and some modules as well. Yeah, quite a few for just one router, one model 2900s. Okay, so let's use it. Why not? To create our network diagram. Okay, so we have a router. That router should be connected to the internet. So we say cloud, as the easiest one. And let's say which one do we want to use? No, we don't want rain. Oh, here we go. That's not good. Let's use that one, and you can customize and say fill, and let's say something like that. And then here you say that's not good. Okay, so let's go for, let's say that cloud. Why not? Internet. That's the internet. And this router should be connected to the internet. So we take connector, and in here, I'll just zoom it in for you. Yeah, we want this port to be connected to that cloud. Okay, and of course in here, when you go for line, you can change and say, well, I want it to be like that, and don't need that, and I am okay to use gray. Here we go. Now what else do we need? Well, we need a switch. However, put network switch, okay? Because if you put just a switch, it will show you 700 options. Rack mounted equipment. Okay, looks good. Yeah, that looks good. Let's zoom it in again. And because it's should have the same size, so let's do it. Here we go. Yeah. Oh, this one is cool. Nah, it's not. Okay, and again, you can download it from Cisco and some other companies if they prepared Visio objects. Okay, and our switch should be connected to the router again. Okay, so we go for connector, and what will we use? Well, this time we want to use that guy, and it will be connected to just the switch. Do we want? Yeah, let's say, why not? Let's say it will be connected to that port line. Let's say we want to, what color? That looks good. Line. Here we go. And you can modify, yeah? So now I would like to run it like that, and like that, like that. Here we go. Okay. And that is our network diagram. Of course, you can add printers. Let's add the printer, why not? And the PC. Let's put them in here. Let's just move it down. Okay, and of course they should be connected to the switch. Okay, our first network diagram. Okay, I know, it's not really impressive, but I will show you a real network diagram that I used in my CCNA training that is available here on Udemy. I'll show you that. That's what I used. And this is a real network diagram that I created for a client a few years ago. Of course, I removed all names, IP addresses, and so on. And this is a real network diagram. I'll show you what is on it. So we have our local area network with 4 switches. Take a look, redundancy everywhere. An access point, 2 firewalls, and switches. And you can ask, why do we have a switch over here? It's just, I thought switches were for local area network and it is like connected to the internet. Well, it is, because it is called a WAN switch, wide area network switch. And this is a special switch that allows you to, for instance, set up a failover pair of firewalls. Yeah, because they have to see each other on the outside interface as well. Network diagrams.
Okay, hi Ed. Thank you very much for joining me tonight. I really appreciate that.
Pleasure.
Can you tell me a little about yourself and your career in IT, please?
Yes. Well, it's been over the last 10 years or so, I've built up my IT skills, and I've grown in confidence through practice and through some training as well. So I was doing jobs where I was dabbling in IT just to help me along, and I thought, well, I could develop this into more of a career. Some jobs where I'd have to do data entry, that kind of thing, and then look behind the scenes at the databases and how things worked. And so I learned a bit of database programming, just simple stuff, and just kept building on that. That's where it started.
Okay, and you used to be an IT trainer as well.
Yes.
Why did you decide to go that route?
Well, I'd done some teaching, science teaching, and wanted to move away from that into, going back to developing the IT skills, but this kind of used a bit of my teacher skills and the IT skills I developed. And I kind of learned a lot through teaching, actually. I was a stronger IT person after 3 years of training than I was at the beginning. And now I'm actually in an IT support role, and I do IT consulting where I use some of what I taught. So I had to learn to teach. I had to learn the IT in order to teach it at the beginning. So it was tough to start with, but then I've benefited from that as well.
Okay, and do you remember your interview, your IT interview? Was it difficult to get the job that you're doing at the moment?
Good question. I think, again, actually, in my IT training, when I trained others in IT, part of the training was to do with interviews and how you put yourself across. And so I had lots of practice helping other people, which at the same time I helped myself in how you come across in interviews. So when it came, I was quite well practiced when it came to the interview for my current job. And they were very pleased with me. They said I really stood out. So I'm sure that was practice, really, as much as anything.
Mm-hmm. And do you remember, did you have a technical interview as well?
Yes, I did.
Did they ask any technical questions?
Yes. One key thing I think I'd learned going into that interview was you don't have to know all the answers. It's that fear of looking stupid that can cause you trouble. Actually, what they want to know is, can we work with you? So if somebody asked me a question and I didn't have an answer at the top of my head, I would turn it into a discussion where I would probe the questioner. I would ask for clarification, or I'd just say, if there's no chance of me being able to work it out with them, I'd say I don't know. But I would turn it into a discussion, and often they would appreciate that, because that's what you do in a real work situation. You don't necessarily have the answer at the top of your head. You discuss it, you work it out.
Yeah, so that is a very good point, that you don't have to know the answer. The idea is to show that you know where to look for an answer, for instance.
Yes.
Yeah?
Yes, you have approaches to solving things, not necessarily all the answers.
Okay. And what do you want to do next? Do you want to keep your job in IT? Is it a good area? What do you think about your future in IT?
Yes, it is a really interesting area. I think if you learn to love learning and not be too intimidated by failure, like I say, that's a big one, is taking the fear and the intimidation out of it. Just almost like that thing I've described about the interview is a parallel with your working life, that if you're frightened of making mistakes, you're frightened of looking silly, that can just make it a miserable experience. But actually, if you try and deal with that fear and you're operating out of curiosity, out of passion for what you're doing, out of interest in relating to people, then you go a lot further, I think. And so I enjoy that side of it. I enjoy the human side mixed with the technical side, the kind of working in a team, and seeing that you're actually helping other people is more rewarding than I realised. You're not trained to think that way. You're trained to think, oh, just pass exams, tick boxes. But actually, helping other people has got quite a reward to it. It's quite enjoyable to see that you've helped someone else.
And what is your favorite technology, the area that you want to focus on and keep your skills up to date? Is it Microsoft, networking, voice, support? Maybe you want to become a manager in a couple of years.
Yeah, I think again, that question in a way draws on the previous answer. I think I'm a bit of a natural consultant. So I enjoy coming alongside other people, helping to identify areas of weakness, sometimes trying to find software tools that can help them to do what they do better, and encouraging them in their learning, and also trying to find solutions myself. So I'm a bit of a sort of people and technology person. I enjoy that consulting, but not just going and talking at people, trying to actually make concrete changes that improve how they work.
Okay, and what can you advise? Because a lot of people, they're afraid, they don't want to start their career in IT because they're afraid they can make a mistake, and sometimes it's a serious thing in IT.
Yes.
If you make a mistake, you can bring the whole network down, you can break a laptop, you can crash a database. What is your view?
Yeah, good point. It's not always about eliminating fear and caution. If you're a surgeon, then you don't want to just do trial and error. You want to get it right. But if you think, I read about successful entrepreneurs and so on, they often don't actually take massive risks. They break things down and they take steps that are measured risks. So it's learning to assess what is a high risk thing. So if you're working on a database, where if you enter the wrong command, you could delete lots of live data that's going to affect a lot of people very quickly, then you make a copy, you work on a copy, and then you do the same thing once you've tested it, you do the same thing on the live version. So you learn ways to reduce the risk.
Okay, I'm not sure if you agree that you should learn from your mistakes, and that is a very important thing and feature of an IT guy, that you learn from your mistakes, because you will make a lot of mistakes anyway, but you try and create a procedure or do something to avoid them in the future.
Yeah, and that's part of the value of teamwork as well. Good critical thinking and critical discussion, where you if you have strong working relationships, you're more able to speak truth to each other.
What is your view on certificates in IT? Because I know you're certified in many areas. What is your view on certificates, please?
IT certification, it's an interesting question. Perhaps my view on certification in general. Again, back to the surgeon analogy. You wouldn't want someone operating on you who just told their interviewers that they happen to be interested in the subject and have done some in Guatemala for a few years. You want someone who's certified. So there's some contexts where I think certification is very valuable. We're in a very mobile society, and it gives people something definite to assess you by. That said, it can be abused. So it's one method of establishing trust, and there are other methods of establishing trust. The quality of your work, your reputation, a portfolio. So I see it as one amongst several ways of establishing trust, and which can lead to employment or clients or whatever. And I think you need to. The education system tends to make it the only method of establishing trust, because that's what they produce. They're, like a sausage factory produces sausages, education produces certification. Tend to say that's it, sink or swim based on certification. I don't think that's the case, but I think it needs to be in its proper place. It's essential, and in certain contexts, absolutely essential. But it's not the only thing. You need to develop as a person, and not just think you're a walking certificate.
Okay, and are you thinking about any certificates?
Well, I've looked at some, and it's interesting again. I've now look at ones that mirror my actual skills in a way. So I've been doing a fair bit of Linux server administration and a bit of MySQL, moving into more web development, learning web development at the moment again. So
because you have a few Microsoft and
Yeah.
Comptia certificates,
yeah, I've got
right?
Comptia and Microsoft. So I want things that show what I can actually do, or what I'm hoping I will be able to do soon.
Yeah, that was my point, that it's not enough to be certified. You have to have some experience. It doesn't make any sense to get 25 certificates with no experience, if you agree with me.
Yeah, yeah. And also you can learn to do exams, and you can learn to play the game of what an examiner might expect by looking at past papers or that kind of thing. Well, you can learn from it. You learn a lot from it, but you don't necessarily learn all that you need to be effective in a job role.
Okay, thank you very much for your time. I really appreciate that. Good luck with your career and your Linux exam.
Thanks very much.
Thank you very much.
General networking, network fundamentals. How can we improve a wireless connection? There are a lot of things that you can do if your wireless is slow. Here is a list of things that are really important and you can do to improve wireless connections. First of all, you have to have a realistic expectation for wireless performance. We have already discussed wireless standards and what you can get from a wireless access point. Please be aware that wireless is not as reliable as a wired connection. In my opinion, well, I don't want to say it will take 500 years to make it as reliable as a wired connection. Yes, I can say that. It will take a lot of time for a wireless connection to replace a wired connection. Second of all, position your router. It sounds like a pretty obvious thing, but a lot of people forget to do that. If your wireless is slow, or I don't know, it disconnects every 15 minutes, try and move your router to a different place. What I mean is, if it's in your living room, put that in your bedroom. And you can say, well, it means it's like I will be 5 feet away, not 1. Well, sometimes it can give you a better signal, believe me. It's all about interference and things that are around you. Check your channel. Any access points around? What you can use an application that is called Insider. That is the screenshot. It will show you all access points, all SSIDs that are in your range. You can compare. Please note here, you can see that this area is pretty busy. You can see a lot of SSIDs, and thanks to that you can go for a channel that is not really busy. Of course, if possible, move to 802.11n 5 GHz or 802.11 AC. It will give you more channels. If possible, I appreciate. In many cases it is not. Try a better USB card. Again, it sounds like a pretty obvious thing. A lot of people don't try it. Most people use a built-in card. When you get a laptop, especially if you pay £300-400 for a laptop, do not expect to get the best wireless card ever. It's not going to happen. If you buy a decent USB wireless card for £30, £40, £50, it can double the throughput that you can get. Upgrade the firmware. Please check, go online, browse, go to the website, see if there is an update for your access point. That can improve the wireless performance as well. The last one is get a business class access point. That's the easiest solution to get a reliable connection. Of course, that is pretty expensive. You can Well, that is at least £150 to get a business class access point. The last thing I want to mention is how can I test my wireless connection. A lot of people use Windows to test it. They browse to a shared folder and they copy some files. That's not the best way to do that. The best tool that you can use is iPerf. However, it's not easy to use. I discussed that tool in my CCNA training if you're interested. I want to show you LAN speed test, which is okay as well. LAN speed test, you can download it from the internet. There is a free version. All you have to do is you have to specify a path to a server or to a folder that is in your network. In my case, I know there is, let me go for this IP address because I have a VPN connection. That's why there are two IP addresses. It's 192.168.129.13 and my shared folder is X. What you can do, you can just press start. Now it's going to ask what is the size of a file that you want me to send. I like to get it bigger, like 100 megabytes. You have to wait a few seconds. It will upload and download a file and show you that in megabits per second. This IP address, it is a wireless laptop. Now it is doing that in the background. What do you expect to see? That's what you can get from a laptop with a built-in wireless card. In this video we talked about wireless networks and I showed you a few tips that you can use to improve your wireless. Thank you very much.
Network, tools and tips. We're going to start with a very interesting tool that can help you find all devices in your home or even enterprise network. Angry IP Scanner. It is a fast and free network scanner. It means you put an IP range and this application will check every single IP address, see if it's alive, and it will allow you to connect to all IP addresses that are online. I'll show you that. You put your IP range. By default, it will include the whole range that you're in. In my case, it is 192.168.129. And then all you have to do is just press start. In a few moments, you will see a list on the screen. Here we go. And it will try and ping. It will try and check, are you alive? .1, are you alive? .5, .10, and so on. Blue, online, red, offline. We have to wait for all hosts. Okay, this is my router, that's my IP camera, a laptop. What else? Yeah, that's it. You can sort by IP address, you can sort here by ping and then see, oh no, there's 12, 13, 14. Yep. So all these IP addresses, all these hosts are online. Now what you can do, you say, okay, I don't know what that device is. First of all, it will provide a host name. And sometimes it can give you a lot of details. Like a lot of printers will introduce themselves as HP and so on. A lot of laptops will have a name that can identify that device. If that's not enough, when you right click,
you can decide what to do with it. What you can do, you can open this IP address using all these services. It means you can open that IP address in a web browser. You can browse to it. If you're more advanced, you can try and telnet, traceroute, and things like that. In most cases, you want to browse to it and see what's available. Thank you very much.